For this question, we notice that the first number is smaller to the second number. So, and the idea is to subtract this second number from the first number. So here now, we should be expecting a negative result. So now, if you want to try it out, we have 1 0 0 0 1 1. We have 1 0 1 1 1 1. So we want to subtract this. 1 negative 1 0. 1 minus 0 is 1. 0 minus 1, is that possible? It's not. So rather we'll borrow. But if we should borrow from this, if we borrow from this to this one become what? The new number here will be what? 2. So when we borrow from this to this, the new number will be what? 2 here, and this one will reduce to 1. From here to here, this one becomes 2, right? And this one too reduce to 1. So this position and this position, we have 1 1 here now to be the new number. So what is 2 negative 1? Is what? 1. Is 1. So here we have what? 1. What is 1 minus 1?
0.
0. Here we have 1. What is 1 minus 1?
0.
0. So now, here we have 0. But here, what do we have? We have 1. You can see that there is an issue. Issue in the sense that, issue in the sense that we have nothing up here and we have something down here. So, and we've known that yes, we can remove something from nothing. And there is no option of borrowing here. You understand? So here, we rather do it in the reverse way. Yes, in the reverse way. So for now, let us restructure the question by taking this one first and this one next. This one is too simple. Let me reframe it. I'm sorry for that mistake with the question No, it won't work like that. You have 0 minus 1. You can't just write 0 minus 1. Okay, 0, we have 0 negative 1. So he said it to be what? Negative 1. So you might be right. So minus 1. Now I'm coming. We'll check it out.
Okay.
We'll check it out together. Now let me just digress a little bit to converting to base 10. So I will use the shorter approach. So now, let's say we want to convert each of these numbers to base 10, right? So now we'll just have to consider that yes, each of these numbers will use the weight of it, because based on each digit, they have a place value. So the place value is like the weight. So since we are working in base 2, so it's going to be multiples of 2. So here now, this first number to the right hand side, talking about this one, can you see the one I'm touching? So it is going to have weight of 1. So if you want to know subsequent weight, you will just be multiplying it by 2. So 2 multiply this 1, what do we get? What will you have? 2, right? 2 multiply this 4. 2 multiply this 8. 2 multiply this is 16. Then 2 multiply this 16 will give you 32. Talking about the weight, which is the place value in this case. So we are trying to look at the shortcut of playing around things. So now we want to convert to base 10. Pardon me for moving because we've not get to that concept. We just want to check whether what we have here is correct or not. But it might be correct. But to be certain of what we are doing. So let us check it out with base 10. So also for this, we will do the same thing. So let's arrange each of the weight based on the position of the digits. So this one will be 1. No, we are working in base 2, right? So that means each of the weights should differ by By 2. Like differ in the sense that it should be times 2, heavier than the previous one. So if you are starting with 1, the next one should be what? 1 times 2. That is what? 2. That is 2. The next one is what? That will be 2 times 2. That is 4. The next one, 8. The next one, 16. Then the next one, 32. So what we need to do with this weight is to use it to multiply the respective what? Value based on their position. So this 32 will multiply 1, 16 will multiply 0, 8 will multiply 0, like that. So, and each of those values will be added together. So whatever thing we have will be the value in base 10. So let's do it together. For this, what are we going to have? 32 times 1 remain as what? 32, right? 16 times 0, 0. Anything times 0 is 0. 8 times 0 is 0. 4 times 0 is 0. 2 times 1, 2. 1 times 1 is what? 1. So we'll add each of these together to get what this one will be equivalent to in base 10. So let's add 32 plus 0, 32. That same 32 plus this 0 is still 32. Plus this 0 is still what? 32. 32 plus 2, that is 34. Plus 1, that is what? 35. So if we convert this one to base 10, it's going to give us 35. So for this other one, let's do it together. 32 times 1, 32. 16 times 1, 16. 8 times 1, 4 times 1, 2 times 0, 1 times 1. So let's add together. 32 plus 16, 48. 48 plus 8, 56. 56 plus 4, 60. Plus 0, 60. Plus 1, 61. So that means we have 35 minus what? 61. So if I should have this, if I should have 35 minus 61, so what will it result to? Minus what? 26. So looking at this 35 is having plus at the front here. Front here is having plus. So the idea is if you have plus, it means you have. Let us explain in terms of money. Plus means you have. Minus means you are owing. Yeah. So now, you have 35 naira. Minus 61 means I'm owing someone 61 naira. You know, I'm owing more than what I have. So if I pay what I'm having, I'm still owing how much? 26. So this minus here is showing that you are owing 26 naira. So we now have to take this 26 back to base 2. So we are just trying to check maybe this answer is correct or wrong. So now, okay.
I kind of got lost at the point where we were
you see all these 32, 16, 8. So those values that is up there, they are just the place value. So based on the position of each digit, there has a value. So and this value, it depends on what, like it will just be the weight of the base number. You know, the base number is 2, right? So that means we'll first start when the weight is 1. So I will keep multiplying by 2 to get subsequent weight number. So I have 1 here. To get the next one, I'll just have to multiply the 1 by 2 since I'm working in base 2. So I have 2. So these 2 result 2. I'll multiply again by 2, 4. 4 times 2, 8, like that. That is how you get each place value or weight of each of those respective digits. So I believe that one is set to right. I can continue. Now this 26, we have it in base 10. So we want to take it back to base 2. Taking it back to base 2, we'll just have to be dividing this 26 continuously by 2. And as we are dividing, we'll be recording that the remainder. So now, I have 26 here. So I want to be dividing it repeatedly by 2. 2 in 2, 1. 2 in 6, 3. So what do we have as the remainder? 0. The 0 is what? Is the remainder. So we go again. 2 in 6, in 13, 6, remainder what? 1, right? So we go again. 2 in 6, 3, remainder 0. 2 in 3, 1, remainder 1. 2 in 1, 0, remainder 1. So our answer is what? 1, 1. We'll take the reading like the answer. We'll read it from the down value to the up value. That is 1, 1, 0, 1, 0. So it's going to be minus 1, 1, 0, 1, 0. So you can see what I'm saying now, that we doing like this will be wrong. You can see the answer does not correlate. Do you get the logic? So that is why I say what? We need to what? To make that conversion to base 10. So after converting to base 10, you do the subtraction in base 10. So you know that it's only this number we want to convert. We have no business with the negative. The negative will still remain in that same position. So we just what? Get the equivalent of 26 in base 10 in base 2. And that is what we just did here. Do we get that?
Yes, sir. I think I have a question.
Okay.
So how do we do our 35 to minus 61?
Okay.
We do it like we just, I know we know the answer, but if we want to like simplify it.
Okay, we'll look at that later. It's part of what we'll be looking at. But let me just what? Answer your question. So the idea is we are converting from base 2 to base 10. It's possible for us to make conversion from one base to another. Now we are looking at how to move from base 2 to base 10. Base 10 is known as decimal system. A number in base 10 is known as what? Decimal number. But the system itself is what? Decimal system. You get? So we want to move from base 2, which is binary, to what? Decimal. That's what we are doing. So, and the idea is what? I have this number. The short way of doing it is we what? Recognizing what? The weight of each of what? Each digit number. So for each of this number here, for each of the number here, they have their own weight. The weight is the place value. Value that is attached to what? To each number based on what? Their position. So now this first value, the weight will be 1. So that is the one that is written up here. So if you want to know subsequent weight, you just have to be multiplying by 2. Because the base number is what? Is 2. Do you get me? So if I multiply 1 by 2, which is the base number of this number. So when you multiply 1 by 2, what does it give? 2. So you multiply this one 2 by 2 to get the next one. 2 again to get the next one. So that is how it works. So if you now want to get your answer, the weight times the value for that position, that is what you will do. So you will do it for each of the values, then you then add all the results together to get your answer in base 10. Do you get it now?
No, that's not my question.
Okay.
After we got it in base 10,
Yes.
how did we do the subtraction?
Oh, okay. So how do we know that 35 minus 61 is minus 26? That is your question.
That's my question.
Thank you. Now, it is very important. That is why I'm trying to what? To take it to money aspect. Do you understand? Because we deal with money every day. We can easily correlate that together. So now, we've already seen that this answer here is wrong. This one is wrong. So let me erase this. So now, how did I know that 35 minus 61 is minus 26? Now, if you have plus, always have it in mind that it means you have. It means you have. And minus means what? You are owing. Owing. Meaning you are owing. Now, for instance, let's say I have plus 2 minus 5. So pardon me for going back, because we are trying to come from what? From the basic to what? To complex. So plus 2. Number one thing is plus means I have. Meaning, what do you have? Money. I have how much? 2 naira. This minus is owned by what? By this 5. Minus 5. It means I'm owing 5 naira. Imagine, you have 2 naira, but you are owing what? Belumi, 5 naira. Now, you can pay the money with you, which is the 2 naira. But will you still be owing Belumi or not? So, the indicator to let us know that, yeah, you are still owing is that negative. So that is why the answer will become minus 3.
So what I'm saying is, if we are going to be using that up-down approach,
okay,
this minus this equals to...
Exactly. So in this case, that arranging of numbers in columns will fail in this scenario. Fail in this scenario in the sense that we won't get what we are expected to have. So there are some certain things in mathematics that the more you keep getting to a particular stage, they will be telling you that what you have been taught initially fails when certain condition would occur. So you'll see that there is invention of a complex number, because mathematicians they encounter with a particular problem of solving a certain equation. That is that give birth to complex number and some other concept. We'll also look at Feynman's little theorem, how important it is to to encryption, like in cryptography. You know, it is very difficult to factorize or to guess very big prime numbers when you multiply them together. And that is what they use for these keys. So it is very very hard to predict or to factorize. So if such number is being used, so we'll look at those manipulations. You know, you when we started, I was talking about number theorem. So saying that it has to do with properties and relationship of numbers. So those relationship and property could be GCD, meaning greater common divisor. That greater common divisor is referring to to our ACF that we are familiar with. We'll look at the computation behind that. And while talking about, when we start the introduction of cryptography as a topic, we'll look at divisibility more as a concept. Prime number also, we'll look at it more in more details. So back to your question. So what I'm just saying is that in a situation where we have small number minus a big number, the arrangement in column method fails in that scenario. So you rather treat it in another perspective. Other perspective in the sense that you might assume that the big number up, the small number down. So subtract the small number from the big number, then you know that your answer should be negative. So that is how we should that is how we are we thought about approach that question. So you see that it will result to the same answer. So I think we can do it like that to compare with what we have there, which is minus 1 1 0 1 0. Please, do we get that? Do you get that?
Yeah, so basically now there's a rule for binary general. It's very close lower than this that once you discover that the number you're trying to subtract is lower, like you have a lower number trying to subtract a higher number.
Okay.
Convert, and just like the base rule.
Exactly.
Like convert, instead of saying you want to use your head to do, just convert to base 10, then when you want to get to the second convert back.
Yes, it's one of the way, because there are different ways we can approach a single question. So another approach that will be more faster. Another approach that will be more faster in this case is we placing the big number up, subtract the small number from it. But in the real question given to us, is the what? The big number that is subtracted from the small, right? So in that situation, our answer should be negative. That means anything that we have afterwards, placing the big number up, then the small number down, well, afterwards subtracting, so the answer should be what? Negative. Should be minus that value. Do we get that? Now let us all try that together. So I want to erase this. We try to digress to what we are here to what? To cover. So pardon me for that.
So,
just to make clarity, that is why.
So what I'm trying to get at is, the instance when we took it back to this thing.
Okay.
We had to do that inverse.
Okay.
Because if we were explaining it to someone that does not know 2 minus 5 is equal to minus 3.
Exactly.
We have to like on it, right? And now add the minus afterwards.
Yes.
So instead of going to step 1, convert, then go to step 2, inverse, then go back and convert. Why don't you just inverse?
Exactly. That is what I want us to do together now. Okay. So let's continue. So this is what we have. See, we notice that the up number is smaller to the what? To the down number. And it's the down number that we are to subtract from the up number. So this is what we are going to do. Anytime we have small number minus big number. So our answer should be minus big number minus small number. Do we get it?
Yeah.
So it's not like we reshuffle it, but in such a way that when we reshuffle it, there will be what? Minus outside. Do you get the concept?
Yes.
So now let us treat what we have inside the bracket. We is what? Big number minus small number. So the big number here is what? 1, 1, 1, 1, 0, 1 minus 1, 0, 0, 0, 1, 1. So it's equal to 1, 1, 1, 1, 0, 1, 1, 1, 0, 0, 0, 1. So we want to subtract. So what is 1 minus 1?
0.
So 0 minus 1 is not possible, right? So here, we need to borrow, right?
Yes.
So when we borrow to this one become what? 2. So what is 2 negative 1?
1.
So what do we have here now?
0.
So 0 minus 0 is what? Yeah, we still have 1, right? So 1 minus 0 is what? 1 minus 0 is what? And 1 minus 1 is what? 0, right? But you know that what? This one is still the same thing as 1, 1, 0, 1, 0, right?
Yeah.
So now, is this the same thing as what we have initially? It's the same thing, right? When we convert to base 10. So that is the ideology in tackling what this. So that means our final answer, our final answer to this, based on this one that we are using, saying small number minus what? Big number, that becomes this. So that means 1, 0, 0, 0, 1, 1 minus 1, 1, 1, 1, 0, 1 will be equal to this negative, of what we have in bracket. The entire bracket result to this 1, 1, 0, 1, 0 in base 2. So we've seen 2 ways of doing it, but this is the fastest of the 2 approach. Let me give you another question to attempt. Okay, you can do this. Also, you can solve this once you are done on addition. So those are the 2 questions. I want to erase this so you remind me of this second question because of space. So what we have here is equal to, we have 1, 0, 1, 1, 0, 0, 1, right? Minus 1, 0, 1, 1, 0, 1, right? So let's do it together. 1 negative 1 is what? 0 negative 0. 0 negative 1 is not possible, right? So borrow from this to this. So this one will become what? 2, right? Let me just indicate it. So that means we have 2 negative 1. 2 negative 1 is what? 1. So yeah, what do we have left here? 0, right? So 0 negative 1 is what?
0 negative 1, not 4.
It's 0 negative 1. So we borrow from this to this. So this one become 2 now, right? Because what we have here initially is what? 0, right? So the new number there is now what? 2. 2 negative 1 is what? 1. So what do we have here now? 0 negative 0. And here we have 0 negative 1. So we borrow from this to this. This one becomes 2, right? 2 negative 1 is what? 1. We have 0 here. So I can decide to write this 0 or I can what? Ignore it, right? So we know that we'll still later ignore it, so there's no need of writing it. So our answer is what? 1 0 1 1 0 0 base 2. So is that what every one of us have?
Yeah. Yes.
Wow. Thank you. That means you are giving me hope that I'm not just talking.
Yeah.
I appreciate that. So one thing is mathematics does require you practicing. So when you what? Practice with more question to be part of it. So the second question, can you help me with that?
1 0
1 0.
1 1
How many 1?
1 0
Plus what?
1 1 1.
How many 1?
3. And okay, we're starting for 0 0
0 1. Like this, right? So it's equal to. So now it's going to be. So we need to arrange, right? So we have 1 0 1 1 1 0 1 plus we have 1 0 1 1 1, right? So now let's add together. 1 plus 1 0, right? So that will be what? 0. We then carry what? 1, right? So this is the 1 that we carry. So 1 plus 0 plus 0, 1, right? 1 plus 1, that will be 0. Then we carry 1. So 1 plus 1 plus 1 will be what? 1, carry 1, right? 1 plus 1 plus 1 is what? 1, carry what? 1, right? 1 plus 0. And we bring this one down. So the answer is what? 1 1 1 1 0 1 0. So now, thanks for that. I really appreciate. So that is how to add and how to subtract number base. So though we make emphasis on binary what? Numbers. So the same way we what? We carry out the addition and the subtraction here. That is how the addition and the subtraction is going to be done on all other base. Maybe base 3, base 4, octal base, decimal, duodecimal, etc. So now, I guess we are. Now let us look at multiplication of binary numbers. How to multiply binary numbers together. So now, have it in mind that there is no how multiplication will be considered that the final product will lead us to what? Addition. So that means, like, there is no how we will multiply without what? Resulting back to addition. So that means for us to get the final result for multiplication, we will need to add. So that means multiplying will still later lead us to addition. And also division will lead us to subtraction. So now, let's use what question? Let's consider, let's say we have 1 1 0 1 in base 2 times 1 1 1 in base 2. So we want to multiply these two numbers in base 2. Since both numbers they are in base 2, we can carry out the what? The multiplication immediately. So now we need to arrange, that is 101 times 1. So now let's do the multiplication together. This first number here will multiply what we are having up here. So 1 times 1, 1. 1 times 0, 0. 1 times 1 is 1. So it's now the turn of this to multiply what we have up here. So 1 times 1, 1. 1 times 0, 0. 1 times 1, 1. So now we'll add. That is why I said what the final what? Product will be done with what? Addition. So now let's add. This one will move down. 0 plus 1, 0 plus 1, and 1 then move down. Very simple. Is it not simple? Simple. So this is our final answer. When we multiply 101 by 11, it's going to result to 1111. So let's say we have this 1 times 101. For instance, each number we have it in base 2. So it's going to be equal to 111 times 101. So let's multiply. At first, we'll start the multiplication with this. Then we'll move to this. Then we'll move to this. So this one, we first multiply everything up here. Then this one will multiply everything up here. Then this one will also multiply everything up here. Do you get it now? So now let's multiply together. 1 times 1 is what? 1, right? 1 times 1 is what? 1. 1 times 1 is what? 1. So it's now the turn of this 0 to multiply what we have up here. 0 times 1 is what? 0 times 1 is what? 0. 0 times 1 is what? Is 0. Then 0 times 1 is what? Is 0. Then we'll multiply with this also. 1 times 1 is what?
1.
So 1 times 1 times 1. So this is what we have. So we then add. So now, this we have this, right? 1. 1 plus this. 1 plus 0. 1 plus 0 plus 1.
0.
So it will be 0. 0 carry 1. 1 plus this is what? So that is 0 carry 1. And this plus this is what? 0 carry 1. So this will be the result when 101 multiplied 111. So we'll stop here.